Alright, for part one of graphing linear inequalities, the very first thing that we have to do is to determine whether or not a point is a solution. Now we did this earlier when we did solving equations. The only difference now is we're going to do it with inequalities. So remember, after we plug in our x and y values, we have to determine whether the end statement is true. Okay? So we're going to start with the point 0, 0. We have 2 points that we have to test. And if I start by plugging in 0 for y, and that's greater than 3 times 0, and then plus 1, I just have to simplify both the left and the right side. So 0 is greater than, well, 3 times 0 is 0, plus 1 is 1. Is 0 greater than 1? This is false, okay, which means that this is not a solution, okay? I'm going to go ahead and check the second point, 2 comma 7. So the 7 is the y value, so that goes in where the y is greater than 3 times 2, and then plus 1. Alright, after simplifying this, I get 7 is greater, 3 times 2 is 6, plus 1 is 7. Is 7 greater than 7? Again, that is not true, that's false. Okay, which means that 2, 7 is not a solution. So neither one of the 2 points is a solution. Now the idea here is, and you're going to see that I'm going to do this again on the second point, is which point is easier to test? Well, I believe that 0, 0 is always the easiest point to test, the origin. Okay, so keep that in mind later on when we get to the graphing. Alright, example 2. We'll start by checking out the point 0, 0. So we've got 0 is less than or equal to negative 2 times 0 plus 3. Negative 2 times 0 is 0, so we're left with 0 is less than or equal to 3. Okay, which means that this is a solution. Okay, so I put yes. Alright, I'm going to check the second point, 3, 9. So 9 is my y value, is less than or equal to negative 2 times 3 plus 3. Okay? Negative 2 times 3 is a negative 6, plus 3 is negative 3. So 9 is less than or equal to negative 3. This is false. Okay? So that means that this point is not a solution. Okay? This one was true, so it was a solution. Okay? So keep that in mind. That's one of the skills that we're going to need to do in order to determine where all our solutions are when we get to the graphing. Alright, so looking ahead here, okay, the second part here is to be able to write the equation into slope-intercept form, okay, and then tell whether or not it would require a dashed or a solid line. Alright, so simple rule of thumb. Anytime that you have a less than or a greater than symbol, you're going to use a dashed line for graphing. Anytime that you have a less than or equal to or greater than or equal to, you're going to use a solid line. Simple reason is that, and it kind of goes back to, you know, your example up here, okay, if it is on the line, okay, you get situations like this where 7 is greater than 7, which are false statements. But if it is, if this had changed to like an equal to, well then it would now be true. So points on the line are true when it's less than or equal to or greater than or equal to, and that's why we use the solid. Okay. Alright, so let's go back to number 3. Okay, our goal is to put it first in slope-intercept form. That means we got to get the y by itself. Okay, so I am going to subtract 3x to both sides of the inequality. That leaves me with y is less than negative 3x plus 7. Okay, negative 3 is my slope, 7 is my y-intercept. What I'm looking at now is this symbol. Since that's a less than, that means I am going to use a dashed line when graphing. Alright, example 4. I got to get the y by itself. So I am going to subtract 2x to both sides. When I'm done, I'm left with this negative 3y, so negative 3y is greater than or equal to negative 2x plus 9. Remember, these are not like terms, so I can't combine them together. Next, to get the y by itself, I divide by a -3, divide by a -3, divide by a -3. Reminder that anytime that you're dividing both sides by a negative, you got to switch the inequality. So that means that this becomes y is less than or equal to a positive 2/3 x, because -2 divided by -3 is positive 2/3 x. And then positive 9 divided by -3 is -3. Okay? That makes this 2/3 my slope and -3 my y-intercept. Since this is a less than or equal to, I am going to use a solid line. Alright, let's go ahead to the second page. Alright, I'm going to start with simple types of graphs when we get to the graphing. I'm going to start with horizontal and vertical lines. Okay, so when I go to look at this, okay, this y is greater than 5, you have to start by thinking that you're graphing y equal to 5. Now remember, y equal to 5 is a horizontal line that crosses the y-axis at 5. Now, you also have to look at the inequality. Since it's a greater than symbol, we just talked about this, that means I'm going to use a dashed line. So I'm graphing y equal to 5 using a dashed line. Okay, and so that is what I have. Okay, now the second part here is I have to determine where to shade. Okay, because there are a whole bunch of solutions that make this inequality work. Okay, if you think about y is greater than 5, well, 6 is greater than 5, 7 is greater than 5, a million is greater than 5, so there's lots of solutions. So we have to show all of those. Well, I can go back to the idea of testing the origin. If I choose the origin, okay, and if I have that being 0, 0, that means I'm going to plug in my 0 for y. 0 is greater than 5. Is 0 greater than 5? Well, that's wrong. Okay, that's false, which means that I do not want to shade the side that the origin is on. I want to shade all of these points. Okay, so I'm going to shade above the line. And if you want, we could test another point. Like, let's say we were to test this point. Okay, this is the point 2, 7. Okay, 2, 7 means my y value is a 7. Is 7 greater than 5? Yes. Okay, and so that's why I'm shading towards that point. All right, let's look at number 6. Okay, x is less than or equal to -3. I am going to graph a vertical line at -3. Since it's less than or equal to, I am going to use a solid line. So remember, it's going to cross the x-axis at -3. I'm going to graph a solid line. Okay, now I have to determine where to shade. Okay, again, I think testing the origin is easy to work with, so if I test the origin, which is 0, 0, if I plug in the x value of 0 is less than or equal to -3. Again, that's a false statement, so I'm not going to shade towards the origin, I'm going to shade the other direction. So all of these points are solutions to our graph. Okay. Alright, so that's the end of part 1. If you have questions, we will work on them with our practice tomorrow.